Hi there, it's Michael. In this video, I'm going to introduce a new plugin I've been working on called Blueprint Attributes. Its main purpose and goal is to fully expose to Blueprint gameplay attributes and attribute sets for GAS. As you may know, it's one of the few things in GAS that require C++, and that can be very limiting for people and teams that are not used to work in C++ when they want to work with GAS. So that's what this plugin is about. It's trying to alleviate that and make it possible to iterate fully in Blueprint. So in this video, I'm going to try to implement an attribute set, a basic attribute set, to implement elf attribute, a max elf to show some clamping, regen rate to implement a gameplay effect regen, and a damage attribute to show the concept and how you would implement a meta attribute. So yeah, in this project, it's a third-person template, a basic third-person template. The character itself has an ability system component and two abilities. The first one is triggered on click. The second one is triggered when I hit the T button. Both are going to apply a gameplay effect. When I do a trace to my target, if I hit something, it's going to apply an effect to the target, and if I hit T, it's going to apply the same gameplay effect, but on itself. The abilities are already done. The effects it's going to apply are already done. The only thing I need to do now is to actually implement the attributes. The gameplay effect is going to apply is this one, and as you can see, there we don't have any attributes just yet. So how do you create attribute sets with this plugin in the editor? You can jump into the content browser, right-click, use the context menu, navigate to the gameplay category, the subcategory gameplay blueprint attributes, and use this factory. It's going to create a new blueprint for you. You can name it as you wish. I like to prefix them with GBA, standing for Gameplay Blueprint Attributes, since GA is already taken by abilities. And if you do and open the set, it's going to grant you with this blueprint editor. It's a standard blueprint editor, but a bit customized by the plugin with the addition of, for instance, these buttons in the toolbar. And as you can see, it's using this parent class, and this class is exposing most of the attribute set API. So you have post gameplay effect execute, post attribute change, post attribute base change, pre attribute base change, pre attribute change, and pre gameplay effect execute. Either in the form of implementable events or overridable methods. The next thing I need to do now is to actually implement and add new gameplay attributes to my attribute set. This class is a direct child of attribute sets, so it doesn't change the way GAS works. At the end of the day, it's still a attribute set, but this plugin allows to the definition of them in the editor, make a blueprint out of them, and the ability to create attributes. You can use this button to add new attributes really quickly. It's going to do the same thing as you would if you add a new variable there and choose the correct type, but it's designed to make it a bit quicker and less error prone to do so. So let's start with the max elf attribute. I'm going to start with this one, leave everything as is. If you leave the replication option as checked, it's going to make sure that the variable is set up for replication. So using a rep notify, and if you check the rep notify, it's even generating some code for you, some boilerplate. If you select the variable itself, you can see you can tweak the variable, the base value. I'm going to leave it as 0, because the first thing we need to do now that we have an attribute set, we need to grant it to the character. And the way you can do this, here in this basic setup, I'm going to do that on begin play, right after I give my abilities, and I can use the init stats method from the engine. It's part of the ability system component API, and allows you to add a new attribute set to the AC. And as you can see, since it's still a U attribute set, it shows there. And we'll need to pick this class. You can leave the data table as empty for now. If I hit play and show debuggability system, as you can see, we now have a new attribute, max health, added to the character. Its value is at 0. I can change it really quickly in the details panel. If I hit play, it should be at 100 now. The next thing I'm going to do is to add the actual health attribute. Also initialized at 0. Can tweak that there. And now I'm going to actually implement the gameplay effect. As you can see, we iterated in Blueprint, added the variables directly in Blueprint, and we can now use them directly right away in gameplay effects. So without the completion step. So that's already something really nice to have, to be able to iterate that quick and implement the mechanics right there. So the effect to damage will be very basic. We'll just apply some change to the health, and we will going to subtract some health, a certain amount, so 10, from the character. If I switch to the other target and try to apply the effect, it's decreasing the health attribute every time. Just so I have a bit of easier time to check the attribute value, I'm going to use this command, ability system dot debug attribute, and then the list of attributes you want to monitor, health and max health. And if you do, you're going to get this little tooltip that's really handy to see at once the value of all the attributes for all the actors that have them. And the nice thing about it is that it persists across sessions, so you don't have to re-enter the command every time. So now I want to go through clamping, but before doing so, I'm going to add the health regenerate, and I'm going to implement a basic regen effect for the health. I think I have one already done there. It's an infinite gameplay effect with a period of 500 milliseconds. And we're going to add to the health attribute a certain amount. So let's say 10, 2 times a second. This part is a component, is a GE component, so the target tag requirements component that's going to pose the regen effect based on this tag. So if the target has this tag present on the ability system component, it's going to pause temporarily the execution of this regen effect. If I look in game and switch to the other target, when I try to apply an effect, damage effect, it's applying, if you can see, in the owned tags line, it's adding a gameplay tag for 2 seconds. And that's going to be used by the regen effect. Now that we have the regen gameplay effect, similarly to how we granted the set, we now just need to make sure the regen effect is actually applied on being in play. And since it's an infinite effect, it's going to be active all the time until I remove it. But I won't remove it. It's going to be active every time. So now if I hit play, you can see the regen going on the health attribute. There's no clamping done just yet. So that's something already. For clamping, what you can do is either with a data table that you can create really quickly with this button, and then make sure that when you init the stats, you pass in the data table, and using the min and max columns. By default, it's not handled by the engine, but this pound class handles it. So that could be a very quick way to implement very basic clamping for the elf attribute. I could set it to 0 there and 100, and it's going to clamp it in the post gameplay execute in native in this class. The other thing you could do is when you create the attribute, you could choose a different type. So using, instead of gameplay attribute data, which is the standard one, you could use this one, gameplay clamped attribute data, which is the direct child of this one, but it has additional built-in feature for clamping. And that's what I'm going to show. I could maybe recreate the attribute. I could change the type right there. If I look at gameplay clamped, sorry, you can change it like this, but I want to use this instead. Up, reorder them, then I still make sure that the elf attribute is still okay. And if I look at the details panel when I have this attribute selected with the gameplay clamped type, it's a bit different than the standard one. You still have the base value that you can tweak, but you have additional possibilities to set up clamping behavior for both the min and max limit. You have different clamp types, known, float, and attribute based. If I choose known and maybe let it start to 50, it's not doing any clamping. So for the min and max, clamping is disabled. The nice thing about that is that if I set a float and none for the max limit, it's going to implement clamping, but just for the minimum. And max is still going up. So if I wait a bit, it's not going to be clamped at any value. But now that we have a max elf and this clamped struct, I could use attribute based and use max elf. If I look in game now, with the regen going on, it should be clamped at 100 and doesn't allow to go higher. And similarly, with the lower limit, I can go into the negative value. You could quickly create a new min elf, for instance, attribute and use another attribute base if you want to tweak this value and make it a different value than just a static 0. So that's already something. We showed how to add attributes directly in the editor, or to add very quickly clamping for your attributes, or to use them with gameplay effects. The next thing I want to cover in this video is instead of using the elf attribute directly within the blueprint, I'm going to use the concept of a meta attribute to hold the damage. Attributes are often they are replicated, but they don't always have to be. There's this notion of meta attribute that is going to hold temporary data for our calculations, and in this case, we are going to use this damage attribute to translate into when the set sees it, it's going to subtract from the elf attribute. It can be good to use this kind of attributes to separate the logic and have a separation between how much damage do I do and how does it translate into my attribute set in change for the elf attribute. For instance, it could be helpful to have this kind of system if you have a shield attribute and maybe you want to go you want to damage the shield attribute before going through health. So that's one way to do it. Let's start with the attribute itself, and since it's a meta attribute, we don't need it to be replicated. It's going to be just temporary and typically reset after each calculation. So that's not a clamp. I don't need it to be clamped, although it would work the same. But just gameplay attribute data is enough. And now instead of using the health attribute directly, I'm going to use damage. For the type, the modifier operation can use add or override. Doesn't matter for this case. And we make sure that this time we are passing a positive value. But if I look in game now, the effect is still applied, so the regen is paused, but health doesn't change anymore. So that's what we are going to do, and it's a good opportunity to show that you can use this post-gameplay effect execute. That's the typical place where you would implement such a mechanic and implement the logic to handle a meta attribute like damage. To do so, you typically compare the parameter for the attribute and see if it's the damage attribute or other one. A quick way to do so is to use the switch on gameplay attribute node, adding a new case for this one to have a new pin there and set it to damage. But since I want access to local variables, I'm going to convert this event to a function like this. Yep. And what do we want to do for damage? It's going to be very simple, but we will need first to get the value of the incoming damage, maybe get the value of the health attribute, the current health for the character, maybe do some checks to ensure that the incoming damage is positive, that we still have some health for the character, it's not at 0 or below 0. And eventually we want to update the health attribute based on the current health and the incoming damage. So it's going to be just health minus local damage, the damage, incoming damage. So yeah, let's start. I'm going to use get attribute value, which is coming from this class. It's available in this blueprint because of the parent class. It's pretty much the same as using get float attribute right there. And both nodes lets you choose the attribute you defined in blueprint. If you have additional ones in C++, it would show there. So we need both damage and health that we're going to store as a local variable. So this one will be local damage and this one will be will be called current health. So that's the first step. When we have a post-gameplay effect execute with the damage attribute, we're going to execute this logic. Okay. Next thing we need to do for a meta attribute like this one, typically we will use set attribute value, which is another method exposed by this method, to set it back to 0 right away, because I have cached the incoming value, and I need to make sure that it's set back to 0. Next thing we need to do, if we want, is to add maybe some basic check to ensure validity of the value, make sure that they are both positive. And if they are, we're allowed to proceed and make change to the attribute value. You could also make sure, but since it's handled by the gameplay clamped attribute, that you're clamping damage so that it's always, instead of checking if it's greater than 0, you can clamp it between, make sure that it's clamp it between 0 and infinity if you want. That could be local damage and max, so that you would ensure that it's always positive. Could also do the same for the current health and clamp it manually this way. But since it's already handled by the struct, I don't really need to clamp it right there. And the last thing we need to do is to set the attribute value for health. And the new value is going to be current health minus local damage. We'll use a math expression because I like them. So it's just current health minus local damage. If you look at it, just the health minus the damage. And now we have it. If I look in game, it's going to execute this method. And if I apply the gameplay effect, it's now doing damage to doing changes to the health attribute like we had before. The nice thing about having something like that is that you can have more complex calculation than just this. So for instance, if I change it slightly to reduce the damage by 2, so I'm dividing it by 2, it's going to apply, instead of 10, it's going to apply just 5. And of course, you can change the actual value, the original magnitude for the damage attribute from the effect. So that's pretty much all I wanted to show in this video. Very quickly, we now have a health, we have max health with clamping, we have a regen effect that's not using the attribute. Actually, I forgot, and the damage attribute. So let's fix the regen effect, and instead of using a 10 static value, we can change it really quickly to attribute based, backing attribute, and now use the regen rate. And if I recall correctly, I don't think I have changed the regen rate. So if I test in game, regen effect is still there, but it's not adding any amount to the health because it's at 0. If I do a 1, now instead of checking for each execution of the gameplay effect, it's not adding 10 anymore, but it's adding 1 based on the regen rate attribute. So that's pretty much all I wanted to show. I hope you will like the plugin, that this video was useful. And yeah, see you next time. Thanks for watching.